This is another problem. This is another problem. You can see here, given as the problem, for a system represented by the following set of equations, find the transfer function x of s by u of s using signal flow graph technique. Instead of giving either block diagram or a signal flow graph, they are given in the form of set of equations. Now, from these equations, we need to draw the signal flow graph and then in turn find out the transfer function x of s by u of s. So, for this, we can, what is the procedure to find out the signal flow graph is, the above set of differential equations are first converted into algebraic equations by taking Laplace transform. So, we shall take the Laplace transform for this. So, as you are all aware of Laplace transform, so I am going to take Laplace transform for equation 1, which is represented by x of s is equal to x1 of s plus beta 3 into u of s. So, here x of s by u of s, always transfer function is denoted by Laplace transform of output by input. So, x of s being output variable, u of s being input variable. Okay. So, now the second, this is supposed to be the Laplace transform of the first equation. Then second equation, its first derivative. So, I will multiply this by s into x1 of s, which is equal to minus a1 being constant, then x1 of s plus x2 of s plus beta 2 into u of s. I want just the variables, that is x1 of s, x of s, u of s as to be, so that I can consider these to be as nodes. So, what I do here is, I just consider what is x of s. So, if I consider what x1 of s, all these terms will be divided by s term. So, minus a1 by s into x1 of s plus 1 by s, nothing is there, into x2 of s plus beta 2 by s into u of s. Okay, call this equation to be 1, this equation to be 2, and now I am going to take the Laplace transform for this. So, this is also a first derivative. So, s into x2 of s, which is equal to minus a2 x1 of s plus beta 1 a2, these are all constants or constant gains, I can say. So, u of s, since I have taken Laplace transform, you are supposed to treat this to be as u of s. As I said earlier, I just concentrate only on the nodes as x2 of s. So, I will be dividing throughout by s here. These s will be divided throughout the equation by giving in this form. So, beta 1 by s into u of s. Treat this to be the third equation. This is how the first and the foremost thing I have done. Given this problem, wherein which I need to find out signal flow graph technique, they are given in the form of equation. The above set of differential equations are converted into algebraic equation by taking its Laplace transform in this way. So, after taking the Laplace transform, I have got the equations as 1, 2, 3 and so on. Now, is to draw with the help of these three equations. With the help of these three equations, equation 1, 2 and 3. Now, I am going to draw the graph. So, as I said earlier, the nodes being input node, output node, as well as these are the intermediate nodes. So, first node is input. So, by the problem I know u of s is supposed to be the input node. So, I have two more variables as x1 of s as well as x2 of s. x1 of s, x2 of s. The output node being the x of s. Because in the problem, this is output, this is input. So, output is denoted as x of s, input node is denoted as x of s. Now, I can treat any of these to be either x1 or x2. For my consideration here, I will be treating this to be x of s, this as x2 of s. You can even convert this into, you can even change this node to be x1 of s or this node to be as x2 of s. But the thing is, you need to satisfy these three equations. Now, first and the foremost thing is, let's concentrate for x1 of s. This is the equation. So x1 of s, or let's take what is x of s only. X of s is formed, this x of s is formed as x1 of s. So the direction will be in this form. So from x1 of s to here, so the gain here being 1 because nothing is here. So x of s is formed as x1 of s plus beta 3 into u of s. U of s is here. I need to draw a diagram in this direction and this being beta 3. Now you can see here, this is x of s. This is the first equation. Consider the equation 1, x of s. So that's why I wrote this to be as x1 of s, because x of s is output, because I can't change this. So if x of s is output node, so x of s is formed by x1 of s plus beta 3 into u of s. So this is how I have written. Now similarly on the on the same basis, now let's form x1 of s. x1 of s is given as minus a1 by s into x1 of s. So x1 of s itself means there is a loop at this with the same direction, because you know very well a loop is the one which starts at the same node and ends at the same node, but its gain being what? A1 by s, this one, plus 1 by s into x2 of s. So 1 by s into x2. So I need to multiply this x2 by 1 by s. So this is x1 of s. So x1 of s is minus a1 by s into x1 of s plus 1 by s into x2 of s plus beta 2 by s into u of s. So from this one more, you can see here the direction being in this manner, because I am forming x1 of s here. So obviously the direction will be in this manner, but here the gain will be beta 2 by s. It will be beta 2 by s. Now the last equation is x2 of s. x2 of s is formed as minus a2 by s into x1 of s. So from x1 of s, I need to have one more, but note here the direction is in the opposite, because now I am forming what is x2 equation here. So x2 is minus a2 by s, minus a2 by s into x1 of s, then plus beta 1 by s into u of s. So already beta 1, u of s is there. So I can just write a direction of here in this manner, signal direction, multiplied by the gain as beta 1 by s. Now the flow, that signal flow graph is ready for me to solve for the transfer function, that is x of s by u of s. All that we have to do here is to find out the number of paths. So we shall just go on finding out how many paths are there. So the first path being this one, that is a straight path from input node to output node, with path gains being beta 1 by s square, because beta 1 by s multiplied by 1 by s becomes beta 1 by s square. Anything multiplied by 1 will remain the same. So the first path being p1 with respective path gain to be beta 1 by s square. The second one, you see here, the second one is this one, that is beta 2 by s into this, because I have just gone only once on this node and then I am going to the reaching the output node. So obviously we can consider this to be another path with path gain being just beta 2 by s. I repeat here, one more path, a node which connects input to output node without traveling to the same node more than once, means, so this is beta 2 by s into 1. So I am reaching the output node, hence I can consider this to be another path with path gain being beta 2 by s. The third one you see here, this one. So the third one being the path gain to be beta 3. So totally we have three paths being having path gains to be respectively. Now is to find out the loops. A loop is a one which starts at the same node and ends at the same node. So L1B, the first one is minus A1 by yes, minus A1 by yes. Let me see whether we have any other loops or not here. So you see, we should see here the second loop being minus A to A2 minus A2 yes. So you see here this is the one which is starting and ending. Yes, I can consider this to be the second loop. This one, it starts at this same node and ends at this same node. So minus A2 by S square. Any others like this? No, I can consider because direction is opposite. And the outer one, yes, its direction is opposite. We have only two loops. So since we have three paths here, so simultaneously I need to calculate delta k for the same. So delta 1, delta 2, delta 3. So delta 1 for this. So first part being a straight path, I need to consider delta to be same as delta, but I need to consider those loops which do not touch the k path. So I have two loops are touching to this, so hence delta 1 will be same. Similarly, the second one is this one. For this also, this loop is also touching, this loop also touching, so hence the delta 2 also becomes 1. The third path is this one. I need to delta 1 is for this path you need to consider the loop which is not touching to that. So both are touching, hence delta 1 becomes 1. Delta 2 is this. Delta 2 is this. Even for delta 2, beta 2 by s square, even for this it is 1. Delta 3 is this one. So for delta 3, both are not touching to each other. So it will be same as delta. So delta is nothing but delta minus 1 minus summation of loops L1 plus L2 plus non-touching loop combination. There are two loops. So first combination itself, if I take, both are touching, so hence there are no non-touching combination. Delta becomes 1 minus L1 plus L2. So delta is same for delta 3 also. Now is to substitute in the transfer function. T of s is given by x of s by u of s. Here I am going to take the same thing. So this is for all values of k, pk delta k divided by delta. Just go on substitute here. So substituting beta 1 by s square plus beta 2 by s plus beta 3 into 1 minus a2 by s square plus a1 by s upon delta will be 1 plus a2 by s square plus a1 by s. So this is how the transfer function is found.